Hello everyone. In today's video lecture, we will show how to perform one-way ANOVA test to determine the difference between different variables. So, as an example, I have shown the disintegration time of three brands of paracetamol tablet. Actually, we need to show whether there is any significant difference among these three variables. So one variable is this represents three brand of paracetamol, and the value has been shown here. There are 10 value of each of the brand. This is ace and this is reset. Okay, so just think that these are uh, three samples and three variables from where we need to calculate whether there is any significant difference between the mean disintegration time of these variables. Okay, so let's perform one-way ANOVA test. Now for this we need to click on data, then come into data analysis. Here click on single factor because it is one-way ANOVA test. Okay, so ANOVA single factor, click on OK. That input range, so what should be our input range? So click all of the table column, then click on the level in the first row, then new worksheet. So get the name as result. Okay, and finally click on OK. So you can see your result. Okay, here is my result. As I can see, single factor ANOVA, the summary is has been given here. You can see 10 sample for each of the tablet, then the sum has been given here, and the average has been given here, and the variance has also been shown here. Now let's check the ANOVA test result. First of all, assess this is sum of square between group and within groups. Then df is nothing but the degree of freedom. So between group, how it is calculated? So between group is number of group minus 1. So we have three group. You can see here we have three groups. Okay, so our degree of freedom would be 3 minus 1. So 3 minus 1 is equal to 2. Okay, then within group, so how we can calculate the degree of freedom within group? There is the formula. So here is degree of freedom within group is equal to number of observation minus number of groups. Okay, so our total number of observations are 30. Okay, minus our number of group was 3. So 30 minus 3 is equal to 27. Now mean of square. So how do we calculate mean of square? MS means mean of square. So to calculate this, we need to divide sum of square by degree of freedom. So divide this by this. So if I want to do that manually, you can easily calculate is equal to sum of square divided degree of freedom. Okay, you can see the value. Okay, you can also do that for this value is equal to sum of square divided df. Okay, 0.0875. So I think you have easily understood this. Then our f value, here is our p value, and here is our critical value. So you can see our obtained f value is higher than critical value, which is very good. Okay, then our p value, you can see our p value is very very low, 10 to the minus 10, that is 0.00000 around 90 and 9. Okay, it is very less. That means our result is very significant. Okay, so how do we calculate the f value? To calculate the f value, just we need to divide the between group by within group. So what is the result of our between group? F value would be this divided by this. Okay, you can see the F value. Here is the F value. Okay, so actually you can do that manually. I have shown you how to do that manually because you can easily understand the equation. Okay, then P value you can also do the calculation of P value manually by utilizing by watching my previous video. So our F value is higher than our critical value. Just in one line, if I say the less P value, the more significant our result would be, and the higher the F value, the more significant our result would be. That means always try your best to get a P value less than 0.05. That means it would be significant. Again, always try your best to get a F value very higher. Okay. In one word, F value should be high and P value should be lower. Okay. So keep it in your mind for better understanding. So here our P value is less than 0.05. That means we can easily uh, reject our null hypothesis. That means our null hypothesis can be rejected. So actually, what is our null hypothesis? So here we can see our null hypothesis is that there is no significant differences in the mean disintegration time among three brands. Okay, that means all of them are equal. So our alternative hypothesis is at least one is different, one brand is different. Okay, so as our p value is less than 0.05, that means we can reject null hypothesis, and it means our alternative hypothesis is true, and ultimately there is significant differences exist among three brands. Actually all of the three brands, in case of their disintegration time, there is significant difference. Okay, so this is the overall overview of one-way ANOVA test. If you have any further confusion, please inform me in the comment section. So before finishing, I want to show a drawback of one-way ANOVA test. Actually, by this test, you can only say whether uh, there is significant difference among them or not. Okay, actually, this is a use yes no question. Okay, but a question may arise if there is there any if there is any significant difference, actually among which the different exist. Okay, if you want to know about that, then you need to do some more test. Okay, so one of the drawback of one-way ANOVA is that the one-way ANOVA test cannot tell you which groups are significantly different from another. Actually, which group is different from another is napa is different from ace, or ace is different from reset, because in alternative hypothesis we have said at least one population is different, at least one brand is different. Okay, we have already said this. So the solution to this problem is that you have to do further test, like if the one-way ANOVA test is significant. What does it mean by significant? The significant means there is significant difference. Okay, significant, then perform post hoc test, like Tukey or Bonferroni test. Okay. Now in the upcoming videos I will tell or I'll show how to perform this post hoc test for better understanding, and within this test we will see whether there is any difference, okay, between among them. Okay, so this is all about my one way ANOVA test. Thank you.